Hi everyone, I am Nikunj Bajaj, co-founder at Foundry, and we are building the world's first cloud specifically designed for machine learning and optimized for the developer experience, all the way from model training to monitoring your model in production. And today, I'm going to focus on a very specific part of our solution and explain to you why building an integrated experiment tracking and inference monitoring solution makes sense and give you a demo of our product. But before we dive into the details, let's first understand what is experiment tracking and what is inference monitoring. So when we talk about experiment tracking, the idea is that during all the experiments that you are running during your model training time, you want to be able to track all your model artifacts, model files, model versions, metrics of your model, the parameters with which you have trained your model, so that every part of your experiment is actually reproducible, all of them in one place. And it's important to pay attention that being able to track your model training metrics, model dataset, model performance is part of experiment tracking. Whereas when we talk about inference monitoring, it is about making sure that your system is healthy, your machine learning system is healthy when it is deployed to production. So you want to make sure that your model is performing as well on the new data that it is seeing as it performed during the training time. Your features that it is seeing for your inference data is not very different in terms of the distribution from what it saw during the training time. And again, it's important to note that during model inference, besides monitoring the system uptime and latency, you are looking at the performance of the model on the new data and the distribution of the inference data that your model is seeing. Now, if you're building any system that is beyond a classroom project and you want to be able to derive business value out of it, hopefully it is fitting into an overall machine learning operation stack. And you can see that most of your machine learning models would start from building your data feature pipelines, training your model, and that's where your experiment tracking solution comes in, where you want to track all these experiments and figure out which is the best model that you would want to deploy to production. And in production, you want to monitor that your model is continuing to perform well. So this is where the overall production MLOps stack look like, a very simplified version of it, albeit. You may ask at this point that if experiment tracking and inference monitoring are two different parts of the MLOps stack, why do we want to build an integrated solution? And the answer to that question lies in our understanding of what is an inference monitoring system and what is an experiment tracking system that we discussed above. So let's start by seeing this. We can imagine that inference monitoring would make sense only in the context of training data and metrics. Let me give you an example. Let's say you are building a recommender system and you're trying to predict the probability that a user will click on a particular product that was recommended. If your system is performing 80% accurate, you can imagine that you have built out a pretty good system. And that means your training data performance was about 80%. On the other hand, let's imagine that you're building a credit card fraud detection system. If your model is performing 80% accurate on your inference data, on your new data that it is seeing, it's a really risky system for the world. And that you will be able to figure out if that 80% is good or not in the context of what was the model performance during your training time. Because you would probably not let a model slip in for credit card detection if it was only 80% accurate during training. So that's why the model output during your inference time, the metrics of the model make sense in the context of your training data. On the other hand, similar thing happens for your model input. Let's say your model was trained for product recommendation on the user behavior based on in the month of October. You can imagine that people are buying regular things like shirts, pants, whatever they want to be able to buy. Now, if you put the same model to production in the month of December, where people are buying Christmas gifts, you would notice that the model is not performing as well because maybe people are looking for completely different type of products. And then the distribution of your inference data is very different from the distribution of your training data. And that's why when you are looking at these distributions on your inference, it also makes sense in the context of your training data. And as we know from our understanding of experiment tracking systems, that all these details about the training data, the model performance during the training while time, all of that is anyways logged in the system during your experiment tracking. And ideally, if you're building one production MLOps stack, there is no reason why you would log the same data once to your experiment tracking system and once to your inference monitoring system. So there is some level of data duplication. Besides that, it's also a poor developer experience because developers now have to write completely different type of boilerplate code for their experiment tracking pipelines and their inference monitoring pipelines, and they have to build inconsistent mental models provided by the two different systems if you decided to integrate two different external solutions for these two problems. And there is a very strong reason why we don't have such integrated solutions built out. Because while experiment tracking and inference monitoring seem very well connected from a developer experience and MLOps stack standpoint, they are completely different engineering problems. Because one is happening completely offline, there is less importance on the speed of execution, there is more importance on large data set that is during the experiment tracking. Whereas the other is happening online, the inference monitoring is happening online, and you want the system to perform async, not block your production calls, completely build out a real-time streaming pipeline, and it becomes a really different engineering problem to solve. And that's where True Foundry comes in. So at True Foundry, we are building this integrated experiment tracking and monitoring solution and inference monitoring solution. And we are solving that hard engineering problem so that you don't have to build those integrations yourself. And we are building our solution on top of a popular open source tool called MLflow, which is originally designed only for experiment tracking. And we went ahead and filled in a lot of gaps in their experiment tracking solution. Things like role-based access control, first-class support for dataset monitoring, comparison of different experiments in a very intuitive UI. And we have extended the support to inference monitoring as well. And we did all of this while keeping our focus intent on the developer experience, consistent experience from your training time to your production time. And now we can either look at the screenshots or see a real demo of what we are building. So what you're seeing here is an experiment tracking dashboard to begin with, which comes from your training time. And here you can go ahead and see the details of a particular experiment that you have conducted. So maybe you logged the metrics of your model from your training time, the hyperparameters with which the model was trained. You have logged all the details around your training curves, your system metrics during your training time. And as I mentioned, that we provide a first-class support for tracking your training data and distributions so that it's really easy for you to spot any differences in your train test val data set. And of course, any artifacts that you have logged is all available to view. But the important part is how well this system is connected with our monitoring solution, where once you deploy your model to production, you're able to track your system health generally, that is number of prediction calls that you're receiving, latency, and stuff like that. But more importantly, you can track the performance of your model on your inference data in the context of your training data as well. Because again, you have already logged these details during your experiment tracking time, and there is no reason why you would want to log the same things during your inference monitoring. And of course, you cannot also compute your feature health drift, your feature drift, if you have not logged your training data set as well. So again, for this aspect as well, building your inference monitoring solution in the context of experiment tracking makes sense. Only then you are able to figure out which of your features are drifting, and you want to figure out the distributions of those features which are drifting and are also important. So we provide some charts for you to make sense of that. And again, we also provide similar details in terms of your data health. Maybe there are some features that are expected to have null values, and you would probably not worry about them. But if some other features that were not null during the training time and during the inference time, it is null because some data pipeline is broken, you want to be able to figure those things out. And That's where I end the demo of our integrated experiment tracking and inference monitoring solution. Thank you for listening.